tape in your class. That's because I didn't do so hot. I don't think I did so hot 5th period, so I'm going to redo it. Not that you care, but. All right, so first term here is 6. Okay? In Word, what is that telling me to do to get any general term in this sequence? To get any general term, I'm going to take 3 times the, if that's n plus 1 and that's n, that must mean that's the previous term, right? Okay, so take 3 times your previous term and subtract n from it. And this is my concern is, what the heck are you plugging for n? Right? So help me with the second term. Ready? How do I find the second term? Any general term, I take 3 times the previous. And now I know the previous term is 6, but I'm not going to plug that in yet. What I'm just going to show you is plug in the first term. All right, plug in the first term. Is everyone all right with that? And then we'll plug in 6 in a minute. Minus, now what the heck do I plug in for that n? It's not 6. Okay, it's not 6. You have to recognize, this is the point I'm going to try to drive home, is that n is the same as that n. Whatever number you had plugged in there will go there. So if you take a look back, does everybody see here? See the number I plugged in? 1, yep, this is AKA the power stance right here. All right, 1. Everyone see it? That's all right. I'll be loud enough. Everybody see 1. Everyone see I plugged in a 1 here. Good? So that means for this n, I also plug in a 1. Good? Questions? All set? This will sound good on the recording, I'm sure. We all set there? So now when you find it, now go ahead. What do you want to plug in for? What was the first term? 6 minus 1, so that's 17. How do I find the third term now? 3 times previous, which would in our case would be term 2. Now what are you going to plug in here? They got to match. They got to match. That's what the formula says. Plug in a 2. So now it'll be 3 times, what was the second term? 17 minus 2. I don't know, what was that, 49? Everybody good? Everyone seeing that part? It's tough, because now I'm even going to flip it even more for number 4. Because number 4 also involves an n in its recursive formula. Let's see if we can do this. Let's see if we can do this. Okay, first term was -6. Second term, I take 1/2, multiply it by what? The previous term, which is our case, is the first term right now, minus, you think you plug in 1, but you don't. You got to find where the n's are all by themselves. Okay, hey, this one up above? Yeah, they were right next to each other. Great, but they're not next to each other here. Do you see where there's just another n all by itself? Boom! Right there. And what did I plug in for that? What number did I just plug in for that here? 2. Everyone see that? I plugged in a 2. The n's got to match. So I'm not plugging in a 1 here. It's going to be a 2. Everyone all right? What was the first term? -6 minus 2. Oh boy. -5. Okay, help me out with the third term then. Third term is going to be found by taking 1/2 times the previous term, the second one. What am I going to subtract now? 3, yes. So 1/2 times -5 minus 3. That's a decimal. -5.5. We okay? And look, let's be honest with each other. You're either going to plug in a 1 or a 2, depending on what type of problem. I don't see any other number being plugged in here other than 1, 2, 3, 4, 5 as you go along. Okay. What I don't want you to do, though, is where you see just n by itself to plug in the previous term. No, that's not what we're doing. Anything else you want to ask here? How are we doing with the recursive stuff? Because I got to go on today. As you know, the train doesn't stop in the first semester. Anything else about recursive before I show you a new one? Hi, Kylie. I guess so. Eight, 7. Okay, let's get 9 up. Ooh, that does look intimidating, huh? It's quite a crew here I got to teach 8th period, quite a crew. We went to the farmer's market instead. Was that directed towards me or?
The one at the middle school or the
Troy. We went to Troy. Well, yeah, all right. Glad it got your approval, Grace. Thanks. All right. All right, anyway. Thanks for getting your approval. Okay, find the number 9 here. Find the first 5 terms. This is a little different recursive formula because not only did I give you the first term, I also gave you the second term. And there's probably a reason I gave you the first 2, because you're going to use them to find the third term. Okay, what's the formula say? To find any term, take 3 times. You tell me if this was n plus 2 and then I go to n plus 1, this is another way of just saying 3 times the previous. And in my case right now, what was the previous term? X plus 6 times n plus 2, n plus 1, n. So this would be the term before the previous one. So if x was my previous, what's the term before that one? So 6 times 1. So 3x plus 6. Questions? Okay, now go ahead. How do you find the fourth term then? 3 times. Now what's my previous? 3x plus 6. And now what's the term before that to multiply by 6? X. And you see where we're going on our way here, Kylie? Oh, good. Good question. Anything else from you guys at all? Going? Okay. You ready to... Remember we talked on Friday that sometimes sequences have patterns, sometimes they don't. Well, this one I'm going to show you today does have patterns. It's got a special name. I may have asked this already, but did everyone get a sheet? We're all good? Keep this with you here, guys, all year long. Would you like it hole punch too while I'm up? You sure? Do you need it hole punch, JT? Yeah, sure. Why not? I got nothing better to do. Sure, we'll just hole punch them. I got 3 right now. Any others? I got 3. 2 hole punch, 1 non-hole punch. We're all good? Okay, sure, and I'll deliver them to you. Yeah. Why not? You're welcome. Cost you a piece, though.
Oh, lucky winner.
Thank you. Not a big fan of it. I go Big Red, by the way, if anybody's wondering. Big Red. Could last forever. Big Red? Big Red? Whole supply here. Just bum one of her. Look at that. That's how you do it, ladies and gentlemen. That's how you do it. All right, here we go. I started today's lesson off by giving you a recursive formula. Everyone agrees this is a recursive formula I gave you up here. I'm telling you the first term is 1, and then how do I find any term in this sequence? I take the previous term and add 2 to it. So here's what I'd like you to do right now. Set up a table, the following table. 1 column or 1 row is going to be the term. And the second row I'm going to call A subscript n. So term 1 would be what? Term 2 would be what? All the way up to 7, which is what it asked for. So term 1, 2, 3, 4, 5, 6, 7, what are they? I already gave you term 1 was what? 1, okay. Can you guys find the rest of them? What's term 2? What's term 3 based on what you just told me the formula was? What's term 2? 3, term 3, 5, 7, 9. Okay. There's your sequence right here. There's your sequence. 1, 3, 5, 7, 9, 11, 13. Okay. All right, throw in a little review. I was like, might as well keep you on your toes. Rate of change from last year. Anybody? Rate of change? Yikes. Rate of change from 1 to 6. Anybody remember how to find rate of change in general? The rock, as I call it. Rate of change. Anybody remember? It is division. Oh, Dom, you got it? So y is on top, x is on the bottom. Okay, so y is on top, x is on the bottom. So yes, your 6 minus 1 would be there, but in the denominator. And what was the sixth term again? Because I want to plug it in its corresponding y value. 6 was 11. And what was the term for term 1? What was the answer for term 1? 1, there you go. My rate of change. 2, yep. Change in y over change in x for your rate of change. All right, I think you guys can handle this. Well, I'll throw this out. Period 5 did. So let's see what you got here. I know I add 2 to the previous term. I get that. I get that. That's called recursive. I get that. Can you do this, though? What could I do to the term's position to get the actual term? Meaning, what could I do to 2 to get 3? Same exact rule to go from 4 to 7. Same rule to go from 7 to 13. What could I do with the term's position to get to what the actual term is? Can you give me a rule? Don't tell me add 2, because that's not it. Because if I add 2 to 2, I get 4, but I got 3 out. Can you guys find? Ooh, I think we got it there. Hot stuff, huh? Do we think we have it? Oh, hold on. Let me. Right. Okay, so to find any term, A subscript n, to find any term, I'm ready. You don't want to say previous, though. You want to say take the term number, multiply it by, everyone in your head right now, go ahead, we're on term 2, multiply it by 2 and add. Oh boy. So multiply it by 2, subtract 1. Does that work for the fifth term? Yeah. Multiply it by 2, subtract 1. Let's try. 3 makes it a good to go. Multiply it by 2, subtract 1. We're good? Everyone, yeah? Okay, so it's going to be 2 times, and we'll have a symbol for this in a second. 2 times the term minus 1, okay? So, could you find the 100th term without doing plus 2, plus 2, plus 2, plus 2 in your calculator? Yeah. Could you find the 100th term probably in about 5 seconds? What would you plug in for the term here? 100. 2 times 100 minus 1, you'd find the 100th term like that. Okay, not bad, right? Because that's a heck of a lot better than doing plus 1, plus 1, or plus 2. All right. 1 doesn't make you great. Here you go. Term in this sequence, I'll talk about all this new vocab in a second. Term 1 is 2, term 2 is 5. So 2, 5, 8, 11. Can you guys predict what the fifth term will be? Can you predict what the fifth term will be? Hi, JT. 14, nice job, yep. The fifth term will be 14. Okay, like Jason just did, can you find a rule? And I'm not talking about add 3. Can you find a rule, what I could do to the actual term to figure out what the term will end up being here? So the term's position, what will the term end up being? So how do I go from 1 to 2, 2 to 5, 3 to 8, 4 to 11, 5 to 14? Can anybody come up with the same thing every single time? How do I find any term now without adding 3 to the previous one? Got it, Kylie? Maybe, maybe. Multiply, ready? Multiply term by 3, yep. And that's not good enough though. Subtract 1, yep. Everyone agree that works? Guys aren't bad, not bad. Okay, so let me try to wrap all this together now. Remember our sequence here? 1, 3, 5, 7, 9. What was the pattern here? Well, add 2, right? What was our pattern here? Both times you're adding the same number, correct? So in a sequence, if you add the same number every time, we're going to have a name for it. It's called arithmetic. Arithmetic sequence, which I believe when we get there should be on the next page. Yes, arithmetic sequence. So when you add, we're not there yet. You're not there yet. Turn it back. Okay. Arithmetic sequence, when you add the same number every time. That's called an arithmetic sequence. If you want to call it arithmetic, fine. It drives me nuts, but that's fine. All right, arithmetic sequence. Now, what number did you add the same for this sequence? 3. What about the one before it? 2, right? That number you go by has a name as well. All right, that number you keep adding all the time is called my common difference. All right, again, you may just want to make a note, the number you add by. Or the number being added every time. Okay, number being added every time. So in our case, in this one, my common difference was 3. In the previous one, it was 2. My common difference. That's what you're adding every time in an arithmetic sequence. How do you know it's arithmetic? If I write a bunch of numbers on the board right now, how are you going to tell me if it's arithmetic or not? Add the same number every time. Okay? Add the same number every time. You don't have to write any of this down. Is that arithmetic? Why not? I'm multiplying the same number, right? But what's my rule? You got to add. All right, last one here I'll show you before we get going. Just to make sure. I didn't sneeze. Oh, sorry. Bless you. Stop being so random. Like I swear the guidance counselors got together over the summer and be like, you know what? We're going to put the most awkward seniors we can find together for Carlino 8th period. All right, the most random ones. And we'll put them with the most awkward random teacher. Yeah. Okay, last one. 2, -2, -6, -10. Is it arithmetic? This gets kids all the time. Here's why. People say, you're subtracting 4 every time. You told me I should be adding. Well, isn't subtracting 4 the same as adding -4? So this is arithmetic up here. And what would be my common difference? -4. Okay, not 4, -4. Do we see that? You can add a positive or a negative number and it'll still be arithmetic. All right, back to business then. Remember these rules? I think it was Jason and Kylie gave me, correct? Remember the rules? Okay, that we're going to give them a specific name now. Now you can turn the page. We're going to give it a name called the explicit formula. Okay, the explicit formula. This will find the rule for any sequence. Right? There's many, many parts to it. There's a couple parts you should be aware of. A1, we already know what A1 is, which is first term. And now, remember that common difference I just talked about, the number you add every single time? We're going to refer to that as our D value. Okay, and that's going to be referred to as our D value. All right? Want good news here? I don't need you to memorize that formula. Here's why. It's on that sheet you got as you came in. Take a look at that reference sheet. This is the same sheet you got for Algebra 1 and Geometry. Everyone see the right-hand side where it says arithmetic sequence? There is that explicit formula I'm going to introduce now. And I will give you this on any test or quiz as well. Okay, since you get it on the Regents exam, so no need to memorize it. But you got to know how to use it. All right? All right, here we go. Let's jump right into this bad boy. Find the indicated term using this information. What's it tell me? What's this 10 mean? First term is 10. What's the D value again? Meaning I'm adding -5 every time. And I'm trying to find when n equals 9, basically the 9th term. And I do not, hey, we're done doing this. We're done doing this. Oh, 10 plus a -5, listing them out. We're done doing that. We're done. We're going to start using the formula now. All right? Because I'll show you why that's ridiculous in a second. Other than being 12th graders and you're better than that. Why you don't have to resort to that. Okay, and there's my explicit formula. It tells you everything to plug in. What's your n value? 9. So ready? When I plug in 9, what term? I'm trying to find the 9th term. That's what that means. You're going to find the 9th term of this sequence. What's your first term? 10 plus, what'd you just plug in for n? 9 minus 1. And what's my common difference, D? -5. And now we just crunch it away here. Crunch away with the numbers. And 9th term of this sequence? 13? 13? Oh boy. How about -30? We all right? So yep, make sure you multiply it by, not -5, multiplying it by. That's a multiplication in between here. We all good, ladies and gentlemen. We all good now? All good? Okay. We sure before I go on? That's multiplication in there. It happens to the best of us. Okay, write an equation for the nth term. Here's what I mean by the nth term. It's the same thing that Kylie and Jason gave me before. Write a rule for -8, -6, -4, and so on. Write a rule for me. But you don't need to think about it on your own. You can use the explicit formula I've already given you. So anytime we're asked to find the nth term, I want to bust out that explicit formula. And here's the nice part when you find the rule for the nth term, n stays n. I'm not plugging in any number because I just want to come up with a general formula. $13, you ready to go? 13, ready? What's the first term? -8, nice. N stays n. I'm not going to plug in for it. N minus 1. Okay, remember what this common difference mean? What am I adding every time? 2. So times 2. Now, you guys can leave it like this, but I prefer you clean it up for me. What do I mean by clean it up? What would I like you to do with that 2? Distribute the 2 and then combine anything you can with -8. So go ahead, distribute the 2. Minus 10. There you go. There's the rule. 2 times the term minus 10. 2 times the term. Here's the power of this formula. All right, here's the power. If I now go a part B question and say, hey, what is the 300th term of this sequence? I do not expect you to take this calculator and go -4 plus 2 plus 2 plus 2 plus 2 plus 2 until you get to 300. Where can I simply just plug in 300 now? In for n, and you got the 300th term. Okay, that's the difference between explicit versus recursive. Recursive, you need to know what the 299th term is to find it. Explicit, you can just plug in 300. So saying that now, can you guys find the 20th term without using plus 7, plus 7, plus 7, plus 7 on the next problem? So find the 20th term. Eight, what are you plugging in for first term? 3, how about n? Oh, no. It's telling you, 20th term, right? So 20, yep. The only time I want to keep it n is if I'm just writing a formula for it, okay? And then what are you going by? 7, so that's the d value, yep. Again, guys, the only time you want to leave n is when you're trying to find a equation for the nth term. And what do we end up with for the 20th term? We sure about this one? $1.36. How do we feel using this new explicit formula? Because there's another type of sequence out there other than arithmetic that I got to talk about in a couple days. So I want to make sure you're solid here. Okay. Ooh, hey, look at this. Now he's getting out of control. Now he's getting at. What am I asking for? Number 4. Which term? 99th term. All right. 99th term. Big deal now that we got this formula. I don't have to keep going plus 4, plus 4, plus 4. That's embarrassing now. 0 self-respect. Oh, 3. Ready to give me a little help here?
Oh, yeah.
Look at that. The only one that's there. One person wrecking crew. Oh, I'm not there yet. Can I get a little plug in before I chug along? -8 for the first term. N. 99 terms minus 1, and you're going by 4. Yep. And that ends up being 3. We doing all right? We okay? And then you're like, not bad, not bad. Just when you get to that point, what do I do every day? Rip that self-confidence right out of you. All right, which I'll do with 5. Write an equation. Okay, nth term. All right, so we know n's going to stay n. But I threw you a curveball here. So you're going along, up, n stays n, and right away, what's the problem? What did I not provide for you? Oh, I'm so sorry. So sorry. Didn't provide the first term. But, ready? Let's start thinking about this. We can get to the first term. What did I give you as 11? So you're telling me the 6th term is 11. And what's this negative 11 mean? To get to the next term, I add negative 11, right? Everyone agree? So I need you to start thinking to yourself, talk to your group members, I don't care. How can I go backwards now knowing this information? How can I go backwards? Because sooner or later, you're right, I got to get to the first term so I can plug it in. How can I go backwards? I know, hey, look, to get to the 7th term would be 0 because I'm going to subtract 11. Try to go backwards. How do I go backwards then to keep going here? Thoughts, suggestions. How can I go backwards? Hey, 2. Good talk. 7. Hi. Well, ready? I'm subtracting 11 to get to the next one. So I think I go back. What must have been here for me to subtract 11 to get 11? Yeah, okay. That must have been 22 because I subtracted. Okay, keep going. What must have been the one before that then? What do you keep doing here? Not subtracting 11. I'm adding 11 to go backwards, right? Agreed, everybody? I'm adding 11 to go backwards. Or I think you were about to say subtracting a negative 11, which turns into, there you go. All right, so 44, 55. First term is 66. Everyone see how we got there? You all right with that crew in the back? Let me know here. Everyone else all right? So 66 plus n stays n. What's the d value here? Negative 11. And again, I appreciate it if you guys clean that up. Distribute negative 11 and add 66 for me. I won't know. But the only concern I would have, Grace, is if it's a multiple choice question and they don't leave it like this and they actually clean it up, that you know where it came from. But no, free response, I'd accept anything there. Speaking of anything, negative 11n plus 77. All good? Okay, so now, knowing what we just did, can you find the first term given this piece of information? Feel free to talk it over in your group right now. Talk it over in your group. How can I get back to the first term given the fifth term and what we're going by? Okay, here we go. What do you do in the 1.5 to get to the fourth term? Subtracting 4.5 and you end up with negative 3. Subtract 4.5 again, negative 7.5 minus another 4.5, negative 12, which brings me to my first term, which would be negative. There we go, guys. Perfect. Beautiful job. We okay on going backwards? All right. I think we can get one more in here. Oh, look at that. Trevor has opened up an English language school in Japan. He the man. He began with 26 students, and he enrolls 3 new students each week. How many weeks is it going to be to make him go 101? Any word problem we do, I like to write out at least the first 3 numbers in the sequence to see what I'm dealing with. So how many did he start out with? 26. Week 1. Week 2? 29. Week 3? 32. And guys, I do not want you or I to keep going until I hit 101 and count the number of weeks. I want to use my formula. Any of these values you know already. A1, okay, yep, go ahead. A1 is 26. Any other value you know up here? What's 3? Common difference is 3, yep. Now, this is any given term in the sequence. I want to know when it hits what? What's the n value when I hit 101? All right, that's what I'm plugging in here. Any value, which in this case would be 101. So how many terms does it take to hit 101? So now we can solve that. Oh, a little fire drill over at Eagle, huh? Get the kids out.
Yeah. I know.
326 weeks? Is that what I was hearing?
That's what I got. 101 minus 23 is 78. Yeah. I just get 101 minus 23. Oh dear. 23.
No. Whoa. I'm trying to find out what term 101 is. That's why I left it n here. This isn't, hey, if I plug in 101 here, you're going to find, what you guys are finding is the 101 term of this sequence. I want to know where 101 is in the sequence. So what term is 101? That's why I put the 101 on the left side. I'm not plugging in 101 for n. I'm plugging in 101 for the term, general term. All of this is 101, not just the n value. So it's going to take how many weeks? 26 weeks, yep.
Good job.
Questions there? All right, so tomorrow we'll finish up with 8, and I believe I got something else to do right after that, and then we'll either have a group assignment or just give you guys time to do the assignment on your own, depending on how many people are here. Good job, guys. Good job.